Hello.
Good evening, sir. Could you please share your PPT?
Can you see, ma'am, now?
It is to check whether if it is correct or not.
Okay, sure, sure. No, yes, ma'am.
If there is any problem, please check it with it.
Can you able to see the present slides, ma'am?
Yes, sir.
Can you please share your full screen, sir?
Now it's okay, sir. Dear participants, Welcome to the fifth day of our faculty development program on disaster management and resilient infrastructure. We have had 4 incredibly insightful days exploring sustainable technologies and risk mitigation. Today, we continue our journey into advanced engineering solutions that define modern resilient infrastructure. We appreciate your continued dedication to these evenings and look forward to another evening of productive learning and interaction. Today's topic will be handled by Dr. M. Sumesh, and today's topic will be urban vulnerability. Dr. Sumesh is currently working as Assistant Professor, Department of Civil Engineering, Dayananda Sagar College of Engineering, Bangalore, India. Formerly, Dr. Sumesh worked as postdoctoral research fellow in the Department of Civil Engineering, Faculty of Engineering, University of Malaya, Kuala Lumpur. Before joining as postdoc fellow, he worked as associate professor and head of the Department of Civil Engineering at Care College of Engineering, Tiruchirappalli. Dr. Sumesh obtained his PhD in Materials and Structural Engineering from University of Malaya, Malaysia. Dr. Sumesh attended Indian Institute of Technology, Guwahati, and earned MTech in Geotechnical Engineering. His Bachelor of Engineering in Civil Engineering is from Anna University, India. He has wide range of experience in research and academic and worked in the Department of Civil Engineering at National Institute of Technology, Tiruchirappalli. Also, Karunya University, Coimbatore, India. He has publications in premier journals of civil engineering, including American Society of Civil Engineering, Journal of Building Engineering, Construction and Building Materials, and published 10 research articles in Web of Science and 5 in Scopus indexed journals. 4 patents, also 4 patents. Moreover, he is also an active reviewer of various prestigious civil engineering journals and also contributing as editorial board members. Without further ado, let's start our session. I'm sure this session will be as insightful as the previous sessions. Let's start our sessions. Stay tuned.
இப்போ போயிட்டு வாங்களாடா அவங்க ஏன்டா இங்க இருக்க மாட்டாங்களா
தெரியல அது அவங்க ஃபேமிலி
Sir, you can start the session.
Thank you, ma'am. Thank you for giving me the formal introduction. Firstly, I would like to thank the management of IES College of Engineering, Thrissur, for this initiative, and also special thanks to the head of the Department of Civil Engineering and FTP coordinators for arrangements and giving me this opportunity for having this session. So thank you all. So today, the FTP, the title of the talk session is Urban Vulnerability on Geotechnical and Material Perspective. So as we all know that the rapid urbanization is one of the important stress and nowadays. This is the main of the presentation, the introduction, background study, geotechnical perspective, material perspective, case study, and the concluding remarks. Okay, so as we know that the rapid urbanization has increased infrastructure stresses and vulnerability to the infrastructure in our society. So the main things, the main challenges faced by our infrastructure and the society is, the aging structures. One of the thing is aging structure, climate-induced hazards, and the material deterioration of structures and other related infrastructure, and weak soil conditions, and uh, and improper identification of material and design of structures. Okay, so the civil engineering and civil engineers play a very critical role for the design of urban resilient structures and the sustainability design of infrastructure. Let's move on to the introduction. So what is vulnerability? So vulnerability is the inability. Simply, it is called the inability or weakness to resist the hazard or any damages or any disasters. So the inability of the structure or infrastructure which cannot resist against the response given to the disaster. So resilience, we know that it is directly opposite to the vulnerability. So resilience, we know that the resilience is opposite to vulnerability and refers to the ability of the resistance or how the structures or any systems can recover after the damage or any distress or damage. So how the structure can be positively performed. So that is resilience. So there are many types of vulnerability like physical, social, economical, and environmental vulnerability as we are facing in civil engineering field. So next one, urban vulnerability. So what is urban vulnerability? So this means the urban or cities when it is susceptible to the negative impacts from various stresses like climate changes or economics, or if you see this one figures, many economic hazards or infrastructure problem, so that will impact negative impacts with the various systems, and this one or combination of all these exposure leads to sensitivity and has a limited capacity to solve and recover from the system and infrastructure and also the people. So next one. So why urban vulnerability is needed? So why urban vulnerability is needed? So this one already we know that urbanization in terms of global and national level urbanization refers to the increasing movement of people from rural areas to cities. That is particularly it results to expansion of the urban regions. As we know already, the globally more than half of the world's population now live in urban areas. So this percentage is projected to rise significantly in the coming decades. It will be keep increasing. So that leads to the urbanization and urban vulnerability. So this percentage is one of the main thing and it could be rise uh, drastically in the coming up decades. So developing countries are experiencing this kind of rapid urban growth due to the industrialization and also due to employability and other for getting better access and education and healthcare and so many things related to this towards urban and urbanization. So though urbanization supports economic growth, so even though we are getting some other benefits, it also plays immense the pressure and other negative impacts on existing infrastructure systems, such as we face problem on roads, railways, even housings and water supply systems and energy distributions and transport networks. So all these things are continuously getting affected and getting pressure on the continuous rapid increase in the urbanizations. Okay. And the main problem is now the infrastructure stress under urbanization. We see here the congestion, environmental change, and resource constraints. So these three are the main infrastructure stress under urbanization. So first one is consistence, one of the main issue which we are facing this one. So increased population density results in overcrowded roads, public transport systems, and utilities. So even though we have underground systems and other subset of facilities, even underground infrastructure and other facilities like tunnels and pipelines, even underground foundations and other facilities. So that could also leads to face some of the stresses due to overloading and inadequate capacity to support this kind of higher level urban demands and urban growth. Okay, that is congestions. So another important thing is environmental change. So like natural landscapes and related environmental changes leads to deforestation and soil degradations, as we know all. So that leads to finally reduced groundwater recharge and other climate changes. So this will definitely will rises the temperature, the global temperatures, and increase rainfall, rainfall variations, and flooding in the particular seasonal areas, and also it raises the sea level, sea water levels, so all these things. So these environmental challenges and these things related to directly affect the stability of soils and stability of ground levels and foundations, and it leads to increasing the risk of landslides and also settlement of structures and structural failures. So this is one constraints. So generally, cities consumes large amount of natural resources, as we know, like land, water, even construction materials and energy. So this large amount of natural resources consumed by cities. So limited on resource constraints, so limited availability of suitable, the land and quality of construction materials increases due to these changes, and also leads to the use of marginal and problematic soils. Sometimes we have to use, there is no other uh, chance, or we have to go for marginal material selection when soil problematic soils, for example. That case we have to use, there is no other choice, because limited availability of suitable land and other quality materials. So resource constraints is one of the problem in these administrations. So, so these are the major issues which we are facing due to the urban vulnerability. So that's why we need to go for sustainable geotechnical solutions to enhance the resilience of the infrastructures and the related systems. The next one is urban vulnerability due to geotechnical perspectives. Okay, we see here the urban vulnerability is significantly increased by geotechnical engineering problems. Okay, such as foundation failures and complication of natural hazards, example earthquake and floods. Okay, so these are things majorly major issues which are often affected by the poor urban planning and improper design of constructions and uh, impacts of climate changes. All these things related to this ground instability, foundation failures, and natural hazards like earthquakes and floods. So next important thing is key geotechnical problems related to ground instability and failures. The number one is landslide slope. Another one is soil liquefaction. Okay. So landslides and slope stability. So which we know that which leads to construction on steep, unstable slopes or hillside slopes. You see the figure. Excavation like cutting into natural slopes or removing any lateral supports, like, or in this one will leads to water infiltration from runoff in the urban area, which can leads to higher pore water pressure in the particular use flow related problems in the particular zone. So this will leads to sweep away the buildings, and sometimes the infrastructure in their collapse. Things will happen due to the landslides and slope instability. You see the figure, the depressed flow and the grip and this one related failures due to the higher pore water pressure and water infiltration, all these things under ground instability. So next one is soil liquefaction. So soil liquefaction during the earthquakes and other dynamic impact on the ground. So which leads to, for example, saturated granular soils. So if it is available on the ground, so which can uh, definitely will be behave like a liquid. So will like a liquid, and it will loses its soil shear strength and ability. So this causes structures to sink immediately, like tilting of structures or collapsing, and other in the internal issues, and for a more problem related to structures and any other related infrastructures pipelines and other things will be affected due to the ground stability and the slope stability and soil liquefaction problems. So next one is another key geotechnical problem is ground subsidence and settlement. Okay, we know that the soil is one of the important things in subsidence and settlement. For example, soft and compressible soils. One of the weak soils are shrinkage and swelling soils. Okay, so swelling and shrinkage expansive soils. So that is one of the main which is available in coastal areas like flood plains and the coastal areas. So that area and that zone will leads to excessive and uneven settlements over the period of time. So which causes structural damages and other extensive crackings and other damages in the infrastructure. So the expenses is one of the main problematic side, more problematic side expense ability to cause damage to roads, so which can lead to damage to roads. If you see the figure, roads and foundations and also and moisture level changes immediately that will leads to all the failure of infrastructure, failure and shrinkage and swelling of soil and collapsing of the structures. So groundwater, another one is groundwater extraction. So groundwater extraction in the particular urban area. So over extraction of water, the groundwater now for urban use can lead to a significant land subsidence, subsidence and also destabilization of foundations in the particularly underground structures. So destabilization happens due to the groundwater extraction in the particular urban zones and underground cavities. So underground cavities, the collapses. So underground cavity, if present in the particular area, so that will collapse. Surely that will collapse the soil connectivity and also the structural soil structure the interaction. So that will lead to sudden and severe damages to structural systems. So next, let's move on to the hazard amplification and the infrastructure compromise. Okay, this one also one of the key geotechnical problems in terms of geotechnical perspective. The main thing is hazard amplification. So this one is the inadequate foundation systems and design, and also water management issues, seismic effects. All these things are coming under hazards amplification and infrastructure systems. Okay. The first one is seismic site effects. So loose soil conditions, as already discussed, the expensive soil and locally available soil is very much important, and also significantly that will influence how seismic waves travel in the particular zone. So that effect can be analyzed. Okay, so the soft soil can amplify how the ground shaking during an earthquake, and also increasing the risk and severity of damages on the buildings compared to those built on hard soil or any rock stratum. So how we can compare? So uh, that can be done by local soil conditions, and also significantly how the influence on the seismic waves can be analyzed. If we see the figure here, the first case there is no cracks, uniform settlement, and tipping settlements. We can observe some of the cracks, and also most probably the no cracks even in the tipping settlements, and different settlements occurs with extensive cracks. Okay, so next one, inadequate foundations and designs. So inadequate foundation design using a wrong type of foundations for the particular specific type of soil conditions. So wrong type of foundation on specific available soil conditions, and also inadequate design and construction practices. For example, unreinforced masonry in seismic zones. If you have any reinforced or unreinforced soil structure interaction, and also on particularly on located on the poor soil conditions, and also soil also not compacted properly, and that kind of things leads to directly the structural failures. So that is inadequate foundation and design. Then waste, then water management issues. So heavy rainfall and high groundwater levels. So these things are intensified and mainly the related to climate change and which can amplify the geotechnical risks mainly. And if you see the aging and inadequate infrastructures, so that also like old, very older buildings. So that is mainly often that cannot meet modern seismic or safety standards. So old buildings, so often this kind of problems are noticed. So that is leads to vulnerable infrastructures. So further, if you see, moreover, the complexity of the existing systems and old buildings, how the underground utilities and the old cities are mapped with the particular amenities and facilities. So next one, under geotechnical perspectives, how uh, we need to get for the sustainable geotechnical solutions to enhance the resilience. So now here we can see there is always a growing need of sustainable geotechnical engineering solutions that enhance the resilience of urban infrastructure. So mainly the sustainable geotechnical practices. If you see here, the focus on the improving ground performance. If you see minimizing the environmental impact. The main thing is here soil stabilization. So only by using eco-friendly materials or ground improvement techniques, reuse of waste materials and different designs by using and considering the climate change impacts. These are the different types of soils are available. So the main purpose of soil stabilization is physical, to improve the physical properties of soil. So there are under physical and the chemical stabilization, there are different methods. So electrical and thermal methods and mechanical hydraulic methods available. So to compact the soils. Okay. Next, if we see here the mechanical stabilization using vibro compactions, geocrates, and vibro techniques and chemical stabilizations. All these methods are commonly used for improving the soil stabilization and soil strength. So the main significance is the increases the soil strength without any sometimes the physical we don't add any chemical additives. So without any chemical additives, the soil strength can be improved, and also the physical stabilization is one of the important things on economical and environmental mm, friendly in suitable conditions. So in terms of chemical stabilization, so lime is one of the main chemicals. It has been used for many years. The lime stabilization. Lime stabilization, the quick lime, the calcium oxide is used for stabilizing the clay soils. Particularly for clay soils, the hydrated lime or quick lime is used for clay soils. So the main thing is to reduce the plasticity of the clay soils and also improve the workability, and it leads to the higher improve the strength through the constructions, subgrade construction, embankment, and clay soils, any filling of soils. Next, let's move on to the need for sustainable geotechnical solutions on lime treatment. We see here the expensive soil, the shrink swell soil. So the lime treating expensive soils. So I just mentioned lime offers many benefits to the clay soil, particularly the plastic soils, where specific to expensive soils, the quick lime, calcium oxide is mainly used for treating this kind of plastic soils. And also the readily available soil is readily available material also available. Quick lime, the calciment. Calciment is also one of the material readily available, so which can be chemically ground to reduce the shrink swell potential of the clay soils. So this modification is mainly takes place due to the exchange of ions. We see here the cation exchange occurs between the lime and the marsh clay soils. The calcium oxide Ca++ ion from the calcium hydroxide, which can be replaced by single cation ion in the marsh soil when it is reacted. So this one will reduces the absorbed water layer around the clay particles, which can reduce the thickness of the soil layers. The diffused water layer surrounds the clay particles, and also additionally, if you see this, if you see here, the clay's particles are reoriented after the reactions. It is reoriented from face-to-face alignment to stronger bonding, like more stronger bonding, like edge to edge alignment. We see the figure. Face to face orientation will have a absorbed water layer, the thickness will be higher, and the edge to edge orientation, this alignment will give more compacted soil layers with more strong and durable microstructure, dense layers. Next, there are different materials like lime, cement stabilization, fly ash, and bituminous based material, and other chemical stabilizers, polymers, and sodium silicate, calcium chloride, and so there are so many. Mainly, if you see the fly ash stabilization, this also enhances the compaction of soil and strength of soil, ultimately like lime stabilization. And also cement stabilization, one of the main thing is the OPC, ordinary Portland cement is mixed with the soil. So the main thing is it will improve the strength, but we can go for secondary or tertiary mixed proportions along with the cement to reduce the cement quantity. So cement can be added with a little amount. The fly ash or GGPS or any rises as per any other bituminous based stabilizer or any other chemical stabilizers, polymers, and sodium silicate or calcium chloride. These kind of chemicals can be added. So next one is the significance of using this chemical stabilization. So what is the realignment of the subsoil can be possible through the soil structure changes to from plastic clay to a standard sand-like material, and also it reduces the soil plasticity and also reduces the soil's capacity for volume changes due to the moisture changes in the soil's optimum moisture content for compaction, and significantly it increases the soil strength so after the compaction, and also it increases the UCS, unconfined compressive strength, say strength of soil, CBR, and also plasticity drastically reduces when we do this kind of chemical stabilization, and also immediate and continued strength gain can be achieved within yearly strength gain can be possible, and and also reduction in the volume change when it is exposed to any moisture content, expensive clay, modified clay. If there is any moisture content exposure, that will also that will have the negative impact on volume changes, unlike expensive clay with the moisture exposure. These are the different moisture, different chemical stabilizations and their effects. Next one. Next, urban vulnerability on material perspectives. We see here the material perspective and the weak, variable, and expensive soil. Already we discussed if we have any weak soil or expensive soil on soil structure interaction under foundation material. So that is one of the vulnerability of foundations. So that will leads to cracking on the building of structures, and also this one leads to reduced load bearing capacity of structures. And also this one, if there is no problem, but accelerated degradation may occur due to the due to any sudden impact or dynamic load, any seismic or any flood events in the later stage. So that will immediately leads to accelerated degradation of the structures if it is not in early stage. So the total foundation systems will be subjected to cracking and settlement and even tilting of structures and collapse of structures. So this one mainly due to the, if we see the metal perspective, so this may due to the concrete or any masonry fail, poor compaction, even low quality concrete and cement or any reinforcements, and also the corrosion of steel reinforcements. In this case, similarly, this kind of corrosion of steel in reinforcement concrete due to moisture or chloride increase. So this one also will occur. So if you see the figure, the rusting steel reinforcement exposed to concrete cracks. So this one leads to spalling of concrete due to the corrosions. So chloride increase also affect near the coastal and severe salt environmental areas. And also moisture penetrations leads to weakening of concrete. If you see the cover of concrete, a weakening of concrete cover, and that leads to triggering oxidation of embedded rebars in this concrete elements, and also concrete surface distress also possible due to the metal on metal perspectives, that leads to cracking and peeling of concrete, and also surface losses and rust and strains, if you see the figure here. So these are all the material perspectives and the effects of this one structures. The next one, the what is the solution on materials? So material solution on foundations. If the structure is foundation, so what are the material solution can be adopted? So high performance concrete with high performance at the same time with low permeability. So that leads to one of the solutions for the foundation material, and also use of corrosion resistance reinforcements. So corrosion resistant reinforcements mainly stainless steel. We can use stainless steel or things corrosion resistant reinforcements. Then geotextiles, stabilizers and fillers. This can be used for style structure, the interface material, geotextile, geogrids, stabilizer, and other fillers. So this can be used for foundation and reinforced wall or bridge embankment, and all the geo structures can be built by using this kind of materials. So this will improve the soil structure, interface bonding strength, and the next one, proper mix design and curing techniques. So this is also one of the important things, and also even we can use for foundation or any roads or building foundations, chemical additives and other stabilization methods to improve the durability of the soil structure and resist solution on buildings. So this one are AAC blocks or stabilized earth blocks. So this can be one of the good choice for building. Go for material solution for on the buildings. Okay, so poor quality bricks, blocks, and any masonry units, one of the important things we should not consider. So low grade cement or aggregates or any excessive porous material, so that can leads to degradation of the structures. So low grade cement and aggregates, even the bricks and blocks also, masonry units, anything should be avoided. So we can go for AAC blocks and engineered blocks, and even interconnected wall panels and the blocks. So that can be a good choice for material solution on buildings. And if there is any problem in the material selection on buildings, so that leads to cracks on the walls and slabs, and also that will leads to less reduces the lifespan of the structures, and dampness and spalling and efflorescence on structures. These are different effects of uh, vulnerability on building materials. Next one, bridges. So vulnerability cases related to bridges. If you say here, the corrosion of steel reinforcements and cables, and also other than the corrosion of steel reinforcement, fatigue and wear of material, that's also one of the important things. And alkali silicate reaction, ASR in the concrete, we have to check in bridge construction, desizing and the salts, marine exposures, and also inadequate selection of expansion joints and bearings in the bridges. So these are the different effects and vulnerability cases in the material solution on bridges. Next one, material solution on roads and pavements. So polymer modified bitumen. So that can be used for enhancing the durability of the material in roads and pavements. And also it should not, if there is any improper material, so that leads to extensive cracking, path hole, and rotting on the materials, and also it leads to uneven settlements if there is no proper material on the road selections. So finally, structural failure, and also it will not leads to any safety and other things. It will be the effect of improper modified bitumen, and this can be a good choice. And also use of recycled aggregates and other industrial products like fly ash and GGPS and other SCMs. So other potential SCMs can be used as one of the main byproducts which can be replaced, and also recycled aggregates can be considered. And next one is geosynthetics for subgrade reinforcements. We can adopt for geosynthetics for subgrade reinforcements, and also high performance concrete pavements in mainly particularly in terms of heavy traffic zones. So this can be adopted high performance concrete pavements, one of the main thing in heavy traffic zones, and also the permeable payments in urban areas. So that is one of the main thing to reduce the waterlogging in the particular urban zone. And also the proper compaction and the drainage systems and maintenance, all these things are very much important to get the proper sustainable material solutions on roads and payments. So next, so generally we need to consider some of the things like durability. So on metals perspectives, so durability is one of the main thing. So durability, the metal must be resist environmental degradation like chlorides, moisture, acid resistance. So all these things must be checked before selection of the material. So the durability of the material is one of the important things. So another one is strength performance. So strength performance of the material also very much important. So we have to choose the material which can meet the structural and load requirements. So that is one of the main thing we need to check. And also the compatibility of the material. So how we have to ensure how the compatibility of material, if there is any composites like masonry concrete or steel concrete, so how the compatibility between the metal that can be checked and ensure the quality and compatibility characteristics of the composite system, and also the sustainability. So use of recycled materials like roads and pavements and bridges. How we suggest recycling material with SCMs. So this can be properly analyzed, and how the material can be compromised. The green materials that can be analyzed in terms of smart materials. The incorporate some of the special concrete like self-scaling concrete, fiber reinforced concrete, and composites with the incorporated other the sensors and other techniques. So that can be considered as smart materials. So that will be like composites for long-term monitoring and the durability. So that can be achieved by incorporating smart materials in the construction. So and also the main thing is maintenance and monitoring. So maintenance and monitoring of the structures is very much important. So the periodic inspections for the cracks, corrosion, spalling of the structures. So that can be considered. And also non-destructive testings, NTT, using ultrasonic testings and rebound hammer, cell potential tests, all those things must be considered. And also the preventive maintenance like coatings in the reinforcements, rebar joints, sealing cracks. So all these things are preventive maintenance. And also finally use of IoT and AI techniques and sensors. Even we can provide bridges and buildings for maintaining the real-time health monitoring of the structures and other infrastructures, buildings and bridges. So this one mainly the mainly related to urban vulnerability. Okay, so material degradation as well as geotechnical perspectives. So these things may damages or any degradation related to foundation, buildings, bridges, and roads. All these things. So the main solution is high performance material and green materials, productive coatings, and smart materials, fiber reinforced composites, and also proper maintenance monitoring. So all these things we must consider. Next one, let's see one of the case studies here. So material perspective. So just here one of the case study in the earthquake. So as we all know that 2003, one of the earthquake happened in Iran. The 2003, the bomb earthquake. So the earthquake in December 2003. So it is one of the natural, the severe disaster occurred in 2003. So up to 95% of buildings and infrastructure in the bomb area were completely damaged or destroyed, with 90% of the structures severely collapsed. See the figure, more than 70% of the houses nearby the bomb area will be were completely collapsed and damaged during this disaster, and not a single house was standing nearby the dam area. Around 16-kilometer radius, completely all around the dam area, completely destroyed. The destruction was happened due to this deadliest earthquake happened in 2003. So due to this earthquake, the majority of the area nearby bomb completely cut off the electricity, water supply, and the main important thing is many houses in the bomb area were built by using man-made structure, homemade material they have used, and all are homemade construction material. So not the standard materials. They didn't use any standard labor or any proper materials. There is no earthquake resistance design. So there is no proper building materials used for this construction nearby the bomb area. So those structures were completely built by the local available material, and also, for example, mud brick style and the low standard design and standard conservation. So after the collapse and earthquake, one of the study done by architecture professor from University Central England, they visited the place and they demonstrated the particular area, and they found that the lack of proper good building material. They didn't choose the particular material for the construction, and also the construction techniques and practices also not followed as per the standards. So altogether, one of that could be the main reason for the disaster, the bomb area. So they have reported in this Department of Architecture, one professor from University of Central England, they reported. So the main thing is the material and the choice of material, the lack of uh, the construction practices was one of the major issues in this disaster. So the main thing we need to conclude here is the use of weak construction material. So that is one of the main thing. So many buildings were made up of reinforced masonry or sometimes unreinforced concrete structure or mud brick in this particular bomb area. So that has low tensile strength and also low resistance against earthquake or any shakings. So that could be one of the reasons in terms of weak material. And also they are telling in the report lack of earthquake resistant design. There is no earthquake resistant design in the particular area in 2003. And the reinforced concrete frames there was no reinforced concrete frames. Okay, and also proper beam column connections also not available uh, in the particular damaged structures, and also no shear walls, no ductile reinforcements and detailing not available in the particular structures nearby the bomb area. So this was mm, reported by the earthquake resistance design, and also poor construction quality. So, and also there is no skilled workers and skilled engineers worked in the particular construction. Inadequate workmanship is one of the main important thing, and also the low quality material and the low workmanship, and all these things one of the reason. And also the foundation, in terms of foundations and soil, the construction of shallow foundation on the weak and uh, locally available soft soil conditions. So soft soil conditions, weak soil, only they have constructed shallow depth of foundations. So shallow foundations on weak and soft soil, so there is no proper soil foundation design and the poor soil structure interaction. So that could be one of the main reason for the ground motion failure, and the ground effect also happen due to this kind of earthquake. Size of foundation, depth of foundation, all these things.
Hello, sir. Range problem is there, sir.
They were very old structures and already and also high population in the particular. Yes. Next one, collapse of population density and the collapse of historic structures happened due to the severity of the earthquake. So all from the case study, we observed that the collapses of the bomb area and the nearby structures and infrastructure, the collapses were mainly happened due to the non-engineered buildings. So the weak materials and the absence of seismic design and the lack of the seismic guidance and other things. Okay. So all these things together, the the structure completely failed. The major collapses happened nearby the bomb area, around 16 radius, completely collapsed and damaged. So then, the Iran, the government, they have implemented one of the new institutional framework to rectify this kind of problems in the urban planning and the reconstruction, the reconstruct the city of bomb with the seismic regulations has been implemented, and all these structures can be again rebuilt by using the seismic regulations they have done afterwards in 2009 to 10. So this is one of the geotechnical perspectives. Thank you very much. So just to we conclude that so we need to understand first on the urban vulnerability related to geotechnical and material perspectives, so that we need to understand. And also we need to analyze soil structure interaction in terms of mainly dense urban environment or any dense urban exposure. So we have to analyze the soil structure interaction properly. And also we need to conduct the extensive study mainly on the performance of construction materials, durability of the material. So we have to conduct extensive study, basic study on the material. Material study is very much important. And also we have to explore on the mitigation strategy, how we can expect it. So that we have to study, that we need to explore on the risk of infrastructure. And also we need to encourage and educate some of the interdisciplinary teaching methods and research in terms of academics and research. We have to uh, encourage the interdisciplinary research on the disaster and the disaster management related studies. So these things will definitely will encourage and educate us to build the resilient structures and resilient infrastructure. Thank you. Thank you all.
Thank you, sir. Participant, I request all the participants to turn on your camera for a photo session. I request all the participants to on your video cam for a photo session.
Mm. Mhm.
The photo session is going on. We have to take some more screenshot. So request you to continue in the start video
Mama,
mode.
pure. Böyle hep tudo isso.
After the photo session, we can move to the discussion session.
For the photo session, we have a discussion.
Thank you, everyone. Now we can move to the question and answer session.
Sir, there are some questions in the chat box. I will read for you.
Yes.
The first one is, why is the risk of soil liquefaction higher in dense coastal cities during an earthquake?
Repeat, ma'am.
Sir, why is the risk of soil liquefaction higher in dense coastal cities during an earthquake? Sir, are you audible?
Yes, ma'am. Yes, ma'am.
So there is a question that why
This
is
is the
the
question. Yes, ma'am.
yeah, sir.
So why is the risk of soil liquefaction higher in dense coastal cities during an earthquake? Because So coastal regions, the soil type is very much important. The soil properties completely susceptible to for the earthquake and soil liquefaction, as I mentioned in the presentation. So the granular soils with low shear strength and that will leads to inability of bonding and compressive and shear strength. So that will leads to higher acidification and susceptibility for the soil structure interaction.
Okay, sir, thank you. There is another question that can ground improvement techniques be considered as a tool for reducing urban vulnerability rather than just foundation design?
Ground improvement techniques can be considered one of the tool for reducing urban. So foundation, so design is one of the main significant things. So we cannot skip any the foundation design criteria. So at the same time, ground improvement techniques is one of the main tool. We can consider one of the main tool to improve the weak soils. Uh, we have some of the different soils we discussed, expensive soil, and there are different techniques we discussed, soil stabilization, even chemical stabilization by using quick lime and cement or any other SEMs and other potential material can be used for ground improvement techniques to improve the soil. Depends upon the soil conditions and types of soil. So, and also the properties of soil, uh, liquid limit, plasticity, fines available. So based on that, we can choose different ground improvement techniques. So that is one of the main tool we can use to avoid the vulnerability in the urban area. So, and also we need to consider foundation design. So that we cannot compromise on the design. So that also one of the main tool uh, for the vulnerability aspects.
Okay, sir, thank you. Our next question is that what geotechnical failures have been commonly observed in cities during recent extreme rainfall?
So ground subsidence and instability as given in the presentation. So that is one of the major issues. Ground subsidence and due to the infiltration of uh, water and flood in the particular area, and also ground subsidence and settlement will occur immediately.
Thank you, sir. Our next question is how nearby structures vibration will affecting the nearby structure? How can we determine it?
How nearby structure? Nearby structure vibration will affecting the nearby structure. This one during the any disaster or any particular any event, disaster event or anything. So that time the structural vibrations is it the meaning of the question? Is it structural vibration? How we can?
Sir, our next question is that how the underground cavities are formed.
Improper material selections. The main thing is improper material selections and the improper compaction of the particular ground layer before construction, and the choice of material is the main problem.
Sir, good evening, sir. My name is Anju, and it's a good, very informative session, sir. So, my question is, what is the most effective bioengineering techniques for stabilizing steep slopes in tropical region with a high rainfall?
Stabilizing steep slope.
Yeah,
So, which is on which area you are telling them?
in a tropical region with high rainfall.
With high rainfall.
Yes, sir.
So soil chemical admixtures and additives we can recommend. At the same time, the physical techniques like vibration and soil nailing and kneading, that is also can be recommended.
So, sir, what about nano silica that can be applied in a, say, additive for this type of slopes?
As nanomaterial is also one of the effective and potential material. Nano silica, nano alumina, and silica alumina based material can be uh, used for chemical admixtures.
So a
Uh,
hybrid
uh,
composition is better, right, sir?
yes, ma'am.
Okay, thank you.
Hope everyone completed their questions. So we can move our final part. With that, we come to the end of our session of day 5. A sincere thank to our esteemed resource person for such an enlightening session on urban vulnerability. The insights shared today regarding disaster resilient infrastructure have been incredibly value and thought provoking. So please stay connected as we will resume shortly by 7:30 p.m. for our second session of the evening. Thank you. Thank you all for your continuous engagement. Thank you, sir. Thank you all.
Thank you, ma'am. Thank you.
Is Suhail sir is there?
Ma'am, any question?
Sir, can you please put a smiley or some message in the group, sir?
Suhail Ejaz na ma'am, Suhail Shah.
Yes, sir. Can you please put a message in our FDP group, sir?
Ma'am, on the WhatsApp group or this?
WhatsApp group, sir.
Okay, ma'am, sure.
Hello, Samuel sir. Are you there?
Yes, I'm here.
Okay. Can we start the session?
Sure.
Good evening, all. It's a pleasure to welcome you all to the second session of Faculty Development Program on Green Infrastructure and Climate Adaptation. We are honored to have Engineer Samuel Edicula Thomas to share their expertise with us today. Let me briefly introduce the resource person. Engineer Samuel Ilikula Thomas completed his B.Tech in Civil Engineering from Satyabama University, Chennai, and his M.Tech in Structural Engineering from Christ University, Bangalore. He began his professional career as an assistant professor in the Department of Civil Engineering at Carmel Engineering College. In late 2018, he founded Joffer Developers, a private construction firm specializing in residential building projects. In 2022, along with his wife, engineer Reshma Susan Roy, he co-founded Joffer Designs, an architectural and structural consultancy firm. His areas of expertise include structural design and sustainable engineering. He has published a journal paper on the sustainability of natural rubber latex and base foundry sand in cement concrete. He is a member of the Institution of Engineers India and the Integrated Civil Engineers Association. So we are looking forward to your insights. Let's make this a productive session and take back valuable learning. Thank you, and let's get started, sir.
Thank you, Anu. Thank you very much. So, thank you for a lovely introduction. So, myself, I am Samuel Regular Thomas, presently working as a structural consultant. So, when I got this topic, that is green infrastructure and climate adaptation, I have gone back to 2018 when I was into college. When I was associate professor. So that time in Kerala, government has introduced KTU, that is Kerala Technology University. So when I stepped into college, the first subject I got is sustainable engineering. They gave me this subject because I was a fresher to that college. I was a newcomer, so they gave that subject for me. But when I started teaching that, I understand the relevance of sustainability in our day-to-day life or in our construction. So before going into green infrastructure, let me ask you, do you have any idea about sustainable engineering? Anybody from the audience, do you have any idea about sustainable engineering? Anybody, please? Okay. So sustainable engineering, it's a branch of engineering which deals with giving back to our Mother Earth. Or what we are learning in that is how we can give back to our Mother Earth. Actually, we all are developed now. We have invented, I think, almost everything we have invented. And from where we got the resources, we got all the resources from our Mother Earth, right? But we didn't give anything back to our Mother Earth. Actually, we are taking everything from the Mother Earth. We are not giving anything back to Mother Earth. But thing is that we have to preserve something for our future generation. We have kids, they will be having kids. So our future generation will be coming and we have to keep something for them also. That's what we have to give something back to our Mother Earth. Okay, so coming to the topic. One second. Yeah, coming to the topic about green infrastructure. So as an abstract or as an introduction, actually what is green infrastructure or what is GI? Is it a branch of engineering or is it is there anywhere which is teaching this in green infrastructure, something like that? It is actually a natural-based solution for urban climate adaptation. We all know that our climate is changing day by day, right? Can we predict anything on our climate? Nowadays, I am from Kerala. Nowadays, we cannot predict a rain. It can come anytime. Anytime it can rain. Like we cannot plan anything based on rain. It can come anytime. So one day, like in the morning when we are looking at the phone, the weather says, okay, one cyclone is coming. They will name some lovely name they will give for that cyclone. And that cyclone will come and the news will be like, okay, it's gonna be rain for 2 or 3 days. We cannot predict anything on our climate nowadays. Before it was not like that. Why? Because nowadays the climate is changing very much. Why it happens? Who is the reason? Who made all these problems? Is it animals? No, we, the human, made all these problems because we depend our Mother Earth for anything and everything. And we have like looted all the resources from Mother Earth. And now the Mother Earth start reacting back. That's what actually happening here. So how can we implement this green infrastructure as a solution for urban climate adaptation? That is our topic. Okay, how it will tackle this thing, green infrastructure, that is GI, tackle issues like flooding, heat islands, and water quality by integrating natural systems into city planning. We all are civil engineers, right? In one way or another, we are building our infrastructures. We are the people who is behind all these designs, all these buildings and everything. So whenever we are building or whenever we are designing or whenever we are thinking about a design, we have to incorporate some green into it. I say the word green. We have to incorporate some green into it. This green can bring back our climate. This green can bring back our climate and everything. So how we can integrate GI into our natural systems? We can introduce park, we can introduce green roof, we can introduce permeable pavements, etc. into our designs and planning. It can also manage storm water. It can also like cool areas. It can also boost biodiversity, often proven more cost-effective and multifunctional than traditional gray infrastructure. Okay, now we go to the second color. We go to the second name, gray infrastructure. What is gray infrastructure? All the infrastructures we are building now is gray. That means whatever we are building with cement, we can call it as gray infrastructure. Okay, what we have to do is we have to implement or we have to put some green into this gray infrastructure. Then we can bring back the integrity of our ecosystem, the integrity of our environment. Okay, so let us discuss about the core concept and benefits of green infrastructure. First one is climate resilience. Green infrastructure helps cities to absorb excess water. It can reduce heat and it can also help to improve air quality and protect coastlines from sea level rises. How it can absorb excess water, or we call it as sponge cities. How we can do that? By implementing green infrastructure, by implementing green infrastructure, by implementing more trees, by implementing parks, or by implementing roof gardens and more. These green things, these trees and everything will absorb water. It will absorb excess runoff water and it will keep the water. By that, we can also recharge our groundwater table. Again, it can reduce heat, that is urban tree canopies. We will build all canopies and everything, right? Why can't we build some green canopies? Why can't we build some tree canopies? If we are having some free area, maybe in front of a house or office or something, why can't we build some green canopies? Again, this will improve the quality of air. It is like we have learned in 6th and 7th grade that the tree will breathe in carbon dioxide and it will be breathing out oxygen. The same thing, the same concept here. Whenever we are introducing this green infrastructure, it can improve the quality of air in that area. And it can also protect coastlines from sea level rises. Again, it is a natural protection for our sea level, for our water bodies like our rivers, our streams, etc., etc. Next one is multifunctionality. That is, beyond climate adaptation, GA provides public health benefits. That is mental well-being. If you are planning a park, maybe in a city, whenever we got some free time, we can go sit there. Like, it will like improve our social relationships. It will improve our mental well-being, etc. We can create recreational spaces. We can create habitat for biodiversity, and also we can support for sustainable development goals. Next one is cost effectiveness. Often cheaper and more efficient long-term than concrete-based solutions for managing stormwater and heat. Green infrastructure is cheaper, but that initial cost will be a little high and it will take some time. All these plants and everything, it will take some time to grow up. But again, when we look into a long-term thing, these things will be cost effective. So this is an introduction about green infrastructure, and by using this green infrastructure, how we can control our climate, or how we can adapt our climate. Going to the next slide. Before we talk about green infrastructure, I would like to tell a few things about infrastructures, or what does infrastructure means. What is infrastructure? I think we all are civil engineers. I think all the participants are civil engineers, and we all know what are infrastructures, right? Anything which is made by us, or it's a basic system which is necessary for the smooth working and growth of a country or an organization. So examples are building, transport system, water and power supplies, etc. are infrastructures. So actually infrastructure are the backbone of a country. It's a backbone of a society. It's a backbone of a state, because everywhere we need infrastructures. Whenever our infrastructures are getting more and more improved, our life will be more and more easy. But how we are building all these infrastructures? Again, we will be using our non-renewable sources of energy from the Mother Earth to build up all these infrastructures. Without infrastructures, definitely we cannot bring our economy up. Our economy, for getting a better economic situation for a country or whatever it is, for an organization or whatever it is, we have to build up infrastructure. But whenever we are building, or whenever we are, I always use this word design, because we are the people designing all this. Whenever we are designing some infrastructures, we have to put the same way, the same color, green into it. Then we can make this infrastructure a reliable one, a relevant one, and we can contribute something back. Okay, so the classification of infrastructures. First one is hard infrastructures. Second one is soft infrastructure. And third one is critical infrastructures. Why I'm talking about infrastructures? I'm talking about infrastructures just to have an idea what infrastructure is and how can we put our infrastructure green. Before I say word gray infrastructure, because everywhere when we are doing a construction part, we will be using cement. That's why it's called gray infrastructure. Anyway, we have to depend on that. Then only we can build up something. But when we are building up something, we have to implement this green thing also into it. So in detail, when we talk about infrastructure, the first one is hard infrastructure. So these are the tangible physical assets and systems that forms the country's economy and society. So as example, we say transportation. For a growth of country's economy, we need transportation. Energy, we need dams, or we need power stations or power generation stations to develop the economic of our country. Next one is water and wastewater management. We need all these STPs and all those stuff to treat all the wastewater and everything we produce. More than that, we need buildings, we need temples and everything. No. Next one is, okay, all these things, all these categories come under hard infrastructures. Second one is soft infrastructures. These are the institutions, services, and systems that support human and social development, ensuring quality of life. When we have kids, we have to send them to school. Where we will sending them? We will send them to the best and good school or institution around us. There should be educational institutions. Or whenever we are having some diseases, we will find the most expensive or most super hospital around us, right? What we are seeing in a hospital, initially we will be seeing the building. Then we will see the facilities. Then only we will go to the list of doctors and the education qualification of the doctors and all. First thing is we will be seeing, when we are seeing a hospital, we will see, oh, wow, this is a good hospital. We will be like that. Then schools also, universities also, public safety, police and fire, etc. All these things have to become, all these things should be there to improve the quality of our life. And all these things will come under soft infrastructure. And third one is critical infrastructure. This category focuses on the vital systems whose disruption will have a severe impact on security, economy, or public health. So this critical infrastructure will be there in and around all this hard and soft infrastructure, and they will be keeping everything under control. When there is an interruption, there is a disruption, it will severely affect our security, our economy, and our public health. So what all are things which is coming under critical infrastructures? The first one is energy, the power grids. We cannot tolerate a day without energy. If some natural calamity is happening, and if there's no electricity for a day, our phones will go switch off, our laptops or whatever, everything will go switch off. We will get isolated. Then communication, internet, and telecom. We all are dependent on AI and mobile phones or laptop nowadays, right? Without that, we cannot think of a day. Early in the morning, we woke up in the bird, and the first thing is we just search our phone. Before that, first thing is we will pray. Nowadays, the first thing we will search our phone. Then water. Without water, can we sustain? Before days, we will go out, we will get water and come back. Now the society has grown, the urbanization has come. Everyone is living in flats. So those who are living in flats, they cannot go out and get a bucket of water at all. Everything should they should get everything in one touch, right? Then the wastewater, the management of wastewater, then the financial services, banking, then food and agriculture, etc. So all these things are necessary for the development of a country or a society, or for the development of a person. So these are infrastructures. So what we have to do is we have to build all these infrastructures. There is no other way. We have to build these infrastructures. We have to, but then only we will get the benefit from it. So infrastructures should be there, or the grey infrastructures should be there. We cannot avoid this. But whenever we are building these infrastructures, whenever we are building all these hospitals, all these schools, all these, what do I say, the transportation system, energy management system, and all, we will be taking the raw materials from the Mother Earth. So we are taking all the non-renewable sources of energy, non-renewable sources of resources for developing and constructing all these things. So whenever we are doing this, we have to, again, at the end of this slide, I said we have to add that word, the green, into our infrastructure. That is green infrastructure. Going to the next slide. So our topic is to discuss about the importance of green infrastructure. Or before I say that, as a civil engineer, we need to build and develop this infrastructure in a green method without impacting our Mother Earth, or by preserving it for our future generation. And it is very important. We have to preserve something back for our future generations. Nowadays, our climate is changing. Nowadays, the groundwater level is decreasing. The seawater level is increasing. The height of the Everest is decreasing. Why? The temperature, the overall temperature of the Earth is increasing. What will happen if the overall temperature of the Earth increases? What happens? What happens when the overall temperature of the Earth increases? We have Mount Everest over there. It will melt, and all the water will come into Arabian Sea. Maybe after 200 or 300 years, when we say about Tenzing and Hillary, they are the first people, as per the records, they are the first people who have conquered Everest. When we talk about them, our maybe our small grandchildren, they will stand in front of Mount Everest and say, oh, these people climb this small mountain. Maybe after 200 or 300 years, everything will melt and everything will come into Bay of Bengal or into our oceans. Actually, this is what now is happening. All the ice is melting. What happens if everything vice versa? All the ice melts, and all the what icelands and everything become deserts. What will happen? We have to take all the camels from Sahara Desert to Iceland, and we have to bring all the polar bear and penguins from Iceland to Sahara Desert. We have to exchange everything. So we have to preserve our climate, or we have to do something, and it is a time we have to react back. We have to protect our environment and our climate. So when we talk about green infrastructure, it refers to planning strategies or bringing engineered green spaces into urban environment. It means we have to plan and bring engineered green spaces. What is engineered green spaces? There's a small picture over there. So conservation areas of forested land and all. There's a trees plus planter boxes we can add. We can add parks and urban tree canopies. We can add green roofs. We can add rain gardens, storm curb extensions. We can add permeable pavements. We can which pavements which can absorb water. We can add biosilies. We can add grow zones with vegetation space. We can add all these things we can add in our urban environment, whether it's whenever we are planning a new urbanization method or whenever into a old one, whenever into existing one, we can incorporate all these things to bring that green back, to bring to prevent the runoff water, to make the water to like penetrate into the earth and increase the groundwater table. Okay, next. Now we have to talk about green infrastructure. What is climate adaptation? Because our topic is green infrastructure and climate adaptation. What is climate adaptation? Climate adaptation means taking action to adjust the current and projected impact of climate change. To adjust the current and projected impact of climate change. We are not only focusing on the current impact, but we have to focus on the projected impact also. We have to think what will happen after 50 years. We have to think what will happen after 100 years. If the temperature of the earth is going up, what will happen for our coming generation? We have to think that. Nowadays, anyways, it is low. If it is going like that, what about the ozone layer? What about the carbon monoxide? Like all the carbon monoxide are coming out. What's actually what's happening in Delhi? That pollution, no? How it happens? Because it's an urban area, it's an urban city, fully populated. All the people are there. All of them they are using like motor vehicles and all. Industries are there, and all these things is impacting our Mother Earth. From all these things, we are getting pollution. We are getting pollution from everywhere, and it is impacting our Mother Earth. That is what actually happening in Delhi. And now our government is trying to reduce those pollutions. We are taking measures to reduce those pollution. They could have think this maybe before 10 years. They could have think this maybe before 20 years. At least they could have think it now. They should have started things now. And they have to think after 50 years also. Whenever they are implementing some rules and regulations, or not only Delhi, maybe next day it is Kerala, or next day maybe it may be Tamil Nadu, or next day maybe it may be Mumbai. So everywhere we have to think the current and projected impact of climatic changes. The adaptation measures needs to happen at the local level. So rural and urban communities have a big role to play. It is not only the duty of government, it is a duty of each and every one of us. What we can do? As a simple, I think most of the people are professors from different university or like students from different universities or colleges. What we can do into this, we have to think. As civil engineers, what is our role in it? How we can contribute to it? The first thing is we have to teach people. We have to give a good class. We have to give a detailed class about what's actually happening. I have seen like a comic before, like people having a bag in their back. They have a backpack which have oxygen. Nowadays, we carry water with us, right? When we are going to school and all, we carry water with us. But maybe before 50 years, when our elder generation, when they go to school, they don't carry water with us because water is available everywhere. They have wells, they have open water sources, they have good water sources. So they use that, they drink that water. But nowadays, our kids, they are carrying water bottles with them to school because there's no good source of water available. That's why they are taking water from house and they are taking it to school. Maybe after 50 years, with this, along with this water bottle, they will take an oxygen bottle also because on the go, on the road, they won't get good oxygen because, and at that time, they can use this oxygen bottle. That will happen. We should not do that. We we have to bring our good earth, we have to bring that good old days back. For that, we have to start acting today. Everyone. That's what it's saying. It have to happen at the local level, from the rural and urban communities. They have a big role to play. They have to do that. Then only we can bring our good old days of good mother earth back. The measures include planting crop varieties that are more resistant to drought. Okay, then there's engineering in it, or there's a science in it. Whenever we are planning to do something, we have to get good research. We have to take research, and we have to plant, or we have to do whatever which is possible. Then practicing regenerative agriculture, improving water storage and use. Nowadays, all the building laws and all should have a rainwater harvesting system. Now they have government has implemented. So whenever we are building something, we have to have a rainwater harvesting system, or we have to have a rainwater recharge system. It is necessary. It should be there. All the runoff water, or wherever whichever runoff water is possible, we have to collect it, and we have to bring it. We have to give it back to the earth. We have to give it for the groundwater recharge. Otherwise, what will happen? All this rainwater will run off, and it will go and ends in Arabian Sea. That will happen. Okay, that should not happen. So what we need to do is we have to do measures. We have to take precautions to get this runoff water into our nearby water sources. Next one is managing land to reduce wildfire risk. Wildfire is a main cause of pollution. We all know in Amazon forest and all know wildfire, it will goes to months and months. It is a main cause of pollution. We have to manage land, and we have to reduce the chances of wildfire risks. Next one is building stronger defense against extreme weather like floods and heat waves. How can we build stronger defense? Simple thing is plant trees. It will protect us from direct sunlight. It will give a cooling effect to us. It will act as the leaves, which is falling from the leaves, will act as a sponge. It will absorb rainwater. It will send the rainwater into ground. It will prevent the small shrubs and all. No? As we see in this picture, one side it is green, and other side it is gone. I don't say green, other side it is gone. You can see the soil over there. You can see the cracks of the soil. The soil is like, give me some water. It's like it's opening its mouth to have some water. That is, and see the buildings, I know it's burning. But on the other side, you can see the green, you can see the greenery, you can see the green field, and you can see the brighter sky behind all those good infrastructures and all. Yes, we need infrastructures. At the same time, we have a greenery also to give something back to the Mother Earth. Then we can reduce usage of non-renewable sources of energies and resources. Nowadays, all the electric vehicles and everything is available. We can reduce the usage of petrol. You can use carpooling, all those of stuff we can use to reduce the use of non-renewable source of energy. And also, in sustainable engineering, there's a 3R concept, that is reduce, reuse, and recycle. They said reduce. First one, we have to reduce. If you cannot reduce, we have to reuse. Whenever we have something, we have to reuse it. As much as possible, we have to reuse it. And the last one is we should have to recycle it. For a plastic bottle, no? Again, we don't have to go to the resources to get a bottle, to make a bottle. We can reuse these plastic bottles. So that is a 3R concept which is discussed in sustainable engineering. Okay, next one. Why do we need to adapt, or is it that urgent? Scientific studies shows that Earth is now about 1.1 degree Celsius warmer than it was in 1800. That is about 275 years back. That is 1800. So Earth is about 1.1 degree Celsius warmer than 1800. That means every fraction of temperature increase will affect our environment, will affect our Earth. Now Earth is became warmer and warmer. Now maybe after 50 or 100 years, it will be like it is 2% or 3%, maybe. So this increase in temperature causes rapid changes in our planet's atmosphere, ocean, and ecosystem. The changes in, we all know nowadays our temperature is going up and up. It can rapidly affect our planet atmosphere. All these pollutions and everything is nowadays it is affecting our ozone layer. Nowadays, like the direct ultraviolet rays from sun is directly hitting Earth. Before there was a cover. Nowadays, these cover, we are losing these covers. Okay, then it can affect our ocean. The water table in the ocean is increasing. Whenever the water table in the ocean increases, our land area will decrease. The water will come into the land area. Land area will decrease, and it will affect our ecosystem. So, according to climate models, without significant climate action, the Earth temperature will again shoot up beyond the safety limit in near future. So, what the climate model says, without having a significant climate action plan, the Earth temperature will go out of control. What they say is it will shoot up beyond the safety limit. Now, I think today it have reached its limits. Now it will go beyond the safety limits in near future. Then we cannot bring it back, or for bringing it back, we have to like put more effort and more money into that. Nowadays, if we can limit that, if we can like hold that, then it will be easy for a future generation to bring it back. If we are just leaving it, okay, we will be like, okay, just let it go. Then it will be difficult for our future generation to bring it back. And again, it will not be this much cost effective for our future generation to bring it back. So with every fraction of a degree of warming, it's a very fraction of a degree of warming. It says 1.1 degrees Celsius. Then again, when every fraction increases, the impact of climate change will become more frequent and more intense. And adaptation will become that much harder and more expensive for people and ecosystem. When or if it goes out of our control, then bringing it back will be more headache for us. It will be more expensive for us and for the ecosystem also. Every time nature will have its own like giving back policy. Nature will have a giving back policy. If Earth is losing something, it will try to regain it. An example is if we have a mango tree, maybe 30 years old, and if we are cutting it, how much time it will take for us to cut it? Hardly 2 or 3 hours. Or how much time it will take for us to plant a new plant, and how much time it will take for us to get it as a tree. Again, for these 3 hours, we have to wait another 30 years to bring it as a mango tree or to grow a mango tree. That is what. Whenever it is going out of our control, it will take more time and it will be more expensive to bring it back. So the next one is green infrastructure and climate adaptation. Now we are into our topic, what is actually green infrastructure and climate adaptation. So as civil or environmental engineers, we are the people who contribute into constructing infrastructures, right? We are the one who is behind all these plans. We are the one who is behind all these buildings and all. Maybe civil engineers or architects or environmental engineers. We are into constructing all these things. So we can contribute into constructing green infrastructures also. We can incorporate this green infrastructure or green engineering into our designs. We can do this in our plans, or for all the faculties over here. Whenever you are teaching your students, you can tell them the importance of green infrastructure. You can teach them the importance of sustainable energy, sustainable engineering, and you can like motivate them to contribute more into it. Maybe you may be taking a class of 60, you may be taking a class for 60 students. If you're giving an impact, if you're giving an awareness, maybe 10 of them will do this. 10 of them will get impressed and they will do this. Maybe that 10 can influence another 10, and that 10 can influence maybe another 10. So we have to give a good education. We have to give a good awareness about implementing green infrastructure into our education. And by that, we can like hold on our climate and we can adapt our climate. we can bring back our climate. We can bring back all those good, what we say, all those good old days and all. We are people who decides the plan and process of physical development in the society. So for the society development, we need infrastructure. So we will be responsible for all the development processes. Whenever a client is coming to us, we will get them, we can discuss, they will be sharing their ideas and we will be designing a plan for them. So in that plan, we can add some green elements also. And we can easily impress them. We can easily tell them, okay, we have to do this. Or we can tell them, you go for a vertical garden, you go for a terrace garden, you go for some green area, you go for a rainwater harvesting tank. Okay, so we will plan a rainwater recharge. We will collect all the runoff water from our roof and we will bring it, we will send it to a rainwater recharge near to your water source. We can tell them, or we can tell them that this will recharge your groundwater table. You will be getting good water. You will get all cool effects. So you will get that natural shading from sun. You will get a cool environment. All these things we can implement in this. We can manage and decide on the type of materials, designs, and methods of construction which is more eco-friendly and which can considerably reduce the impact of development in the environment or ecosystem. Again, we are the people behind choosing materials. Okay, our clients or our customers will have their opinions, but we have a word on that. We have a hold on that. We can choose the type of materials. We can design the method of construction. So many eco-friendly construction methods are. We can choose on that. We can give an awareness to our clients about all these eco-friendly methods of construction and all. We can tell, sir, if we do like this, it will reduce the impact on the environment. So if we can do like that, if we can implement this, if we can implement that, all these things we can tell them, we can give awareness to them. To give that awareness, first thing is that we should be aware. We should get the awareness first. Okay. Then we can select the eco-friendly, which is considerably reduce the impact of development in the environment or ecosystem. Anyway, development is necessary. It should happen. Development should happen. Infrastructure should happen. But we can, when we plan that, we can reduce the impact of that development in the environment or ecosystem. So what is green infrastructure? It is a cost-effective tool for climate adaptation. So that's our topic, green infrastructure and climate adaptation. So here is my answer. It is a cost-effective tool for climate adaptation. Whenever we are putting that word green into our designs, and whenever putting that word green into our projects, or whenever we are putting that word green into whatever we do, it will cost-effectively adapt our climate. It will make small changes in our climate. And that small changes will finally begin a big change which can bring our climate back, which can give something to the environment, which can hold the ecosystem. It's by mimicking natural process to increase the resilience of human and ecological system against climate-related hazards. It's called biomimicking. What is biomimicking? Biomimicking means we all know what is mimicking. We all like to mimic others, no? We all mimic cinema, film actors and all. It's the same thing we have to do. We have to mimic the activities of Earth. We have to mimic the activities of our ecosystem. We have to do like that, and it's a natural process, and it will increase the resilience of human and ecological system against climate-related hazards. So how green infrastructure adapts to the climate change? The green infrastructure, or G, adapts to the climate change by following methods. How it will adapt the climate change? The first one is it uses natural systems like trees, park, green roof, and wetlands to manage heat, water, and biodiversity. By introducing green infrastructure, by introducing trees, or by introducing park, by introducing green roof, wetlands, etc., it can manage heat. When we have a tree like beside our house, if we are standing or sitting beneath that tree, we will not feel the heat of sun. Who is protecting us from that? This tree will protect us from that heat. Okay, again, this water and biodiversity. everywhere we can keep this green infrastructure into that. GI offer multifunctional solutions like cooling cities, reducing flood risk, etc. That is sponge city concept and all. That is when flood happens, when it rains heavily, flood happens. Why flood happens? All the runoff water from the rain will come and collect at the lower area, and all this water will go up and flood happens, right? Why all this water is coming like that? Because there is nothing to stop or collect that water. Whenever it rains in a forest, the amount of runoff water will be very less. Why? Because this water will get stuck inside the leaves and all, and it will act as a sponge there, and these water will settle down, or it will penetrate into the earth. So whenever we are building a green infrastructure or whenever we are planting trees or shrubs or whatever it is, these will reduce the flow of runoff water, and it will prevent the flood and everything and other risks involved in all these disasters. GI improve the quality of air and water, obviously. How it can improve the quality of air? The same old thing which we have learned in our 7th grade, that is, a plant will breathe inside carbon dioxide and it gives out oxygen. Same thing. Whenever we are into a place where it is covered with trees and all, a good morning in a morning, when we are standing in a place where lots of trees and there, we can easily breathe in, we can feel that fresh air go inside our respiratory system, inside our lungs. At the same time, you go stand in a busy highway or something, and you breathe, or busy city or something, you breathe. You go stand in Delhi and you breathe. You can feel that dust, you can feel all those pollution and everything, right? So the green, when we are implementing this green infrastructure, it will improve the quality of air and water. It provides shades. GI or green infrastructure provides shades. How it can provide shades? It will provide shade. That is, whenever we are planting a tree, it will provide shades for us, right? It will absorb rainfall. It will filter pollutants and create social spaces. What is social spaces? Whenever we are having a park nearby our house or nearby our society, at least maybe twice or thrice in a month, we will find some time to go and sit there. It's actually a relaxation for us. There we will meet our neighbors. We will get a social space over there. When we are building a city, when we are planning a city or something, plan a park also. Plan a place where our kids can play. Plan a place where we can go and sit. Plan a space where we can sit and we can meet our neighbors and go. In our busy schedule nowadays, we are not seeing our neighbors and all. We will be like waking up in the morning. We'll be like running behind our duties and all, right? When we are running behind our duties and all, where we are getting time to think about GI, we are getting time to think about green infrastructure. So whenever there's a space, we will definitely go and sit. Whenever there's a space with good air and all, we will go and sit. We will spend some time. So GI provides, or GI create social spaces also. GI make urban environment more suitable and livable against extreme weather. Nowadays, our urban environment are getting like everywhere we need AC nowadays, right? Every house, every flat, we need AC because we cannot sleep at night. We need AC. Why? Because our temperature is going up and up. So whenever we can implement this green infrastructure, nowadays all green buildings are coming, or like eco-friendly buildings are coming. What they are doing is on the balconies and they will plant trees and all. They will make measures that like protective measures for our infrastructures like waterproofing and all they will do, and they will plant trees and all, maybe in balconies and all, they will plant trees and so that good air will come inside our apartment. It will restrict the heat from the sun. It will restrict noise from outside. It will restrict all unwanted pollutants from outside. It will filter everything and send whatever all the good things inside, or whatever we need. It will send all the good things inside. So it can make our urban environment more suitable for livable against extreme weather. So coming to the next slide, what is green infrastructure? You can see rain gardens, trees and plant boxes. All these things we can implement in our society, right? Maybe in our house we can implement it. In our living apartment, we can implement it. That stormwater curb extension, we can implement. Green roofs. Green roof means nowadays people are like having all the small things, vegetable gardens and everything over the roof. It's a good thing. One thing, we will get good vegetables, and other thing, it will act as a protective layer over the roof. The one thing we have to do is we have to do proper waterproofing and whatever elements, whatever precautions we have to do, we have to take before doing all these green roofs and all to prevent or protect our slab and everything. That first thing we have to do. Then we can implement all these green roof or what vertical gardens and everything. So it will give a good air or good atmosphere, good ecosystem for us. So key adaptation methods. First one is urban heat island mitigation. Second one is stormwater mitigation, stormwater management. Third one is coastal protection. Fourth one is water quality. So once again. Okay, next one is water quality and air quality. And next one is biodiversity and ecosystem services. So how can we adapt this? How can we adapt into the climate changes? How can we adapt green engineering into climate changes? First one is urban heat island mitigation. Trees provide shades and releases water vapor. We all know that. Evapotranspiration, we all know about it. Significantly lowering the temperature during heat waves, which is very crucial for public health. That is urban heat island mitigation method. Plant more trees. It will provide shades. It will release water vapor. It will provide moisture into our atmosphere, and it will lower the temperature during heat waves, which is crucial for public health. Next one is stormwater management. Permeable surfaces. Biowales and rain garden absorb heavy rainfall, reduce runoff, preventing localized flooding and recharge groundwater, acting like a sponge, etc., etc. What is how we can like control the flow of water, or how we can control the runoff of water. Permeable surfaces. The permeable pavements, other than that asphalt, as our normal asphalt pavements and all, roads and all, we can have permeable pavement surfaces. For a common walkway or something, we can introduce this interlock tiles. And these tiles are having gaps between them. These gaps will absorb the water inside, and this water will be like going down the earth, and it will recharge our groundwater table. Rain gardens, it can absorb heavy rainfall. Otherwise, what happens? It rains, all the water will go into the nearby water sources. And from there, it will go to the nearby streams or pond. From there, it will go to the river, and from the river to the oceans. Nothing is going beside, nothing is going beneath the earth. We have to introduce rain gardens to absorb rainwater fall. Reduce runoff. How we can reduce runoff? We can plant trees. We can plant shrubs. If you have a free space, we can plant grass. It will reduce the soil erosion also, and it will prevent the runoff of water. It will give water little time to get runoff, and by that time, the earth can bring some water in. Okay, and it will recharge our groundwater, and it will act as a sponge. Next one is coastal protection. Restoring natural buffers like eelgrass birds and wetlands to reduce erosion as absorbs storm surge impact, protecting infrastructure and habitats. Okay, what is coastal protection? Whenever we are having a river or something, how we will protect the banks of the river? We can even have a grey infrastructure there. We can build concrete retaining walls. We can build random rubble walls. We can build something we can build, or we can build small check dams and all. Everything we can build. Rather building these type of grey infrastructure, why can't we choose a green infrastructure over there? Why can't we like grow some plants which can prevent soil from erosion? Why can't we like plant some trees at the bank of the rivers? So these will protect our banks. This will protect our coastal areas eco-friendly, in an eco-friendly manner. For the seaboard, for building seaboard, what we are doing, we will make big concrete blocks and we will put it in the bank of the sea or in the like beaches and all to prevent the waves. Instead of that, And for rivers also, we will be building all these grey infrastructures for preventing all these things to prevent it from erosion and all. Rather than this, why can't we use a GI? Why can't we use a green infrastructure to prevent all these things? We have to think about that. Water quality and air quality. Vegetation filters pollutant from air and water, improve overall urban environmental health. Vegetation filters pollutant from air. Same thing which we have studied in the 7th grade. What plants do? It breathes inside carbon dioxide and give back oxygen. Same thing. It will filter the pollutions from air. It can even filter the dust particles from air. It can even filters water, and it will improve overall urban environmental health. Next is. Next, we will talk in detail about urban heat island mitigation. The first one is this process involves strategies like adding green infrastructure for shades and moisture. One second. Okay. This process involves strategies like adding green infrastructure for shades and moisture, release cool materials to bounce sunlight away, improving urban design for better airflow, and constructing energy efficient building. So what it do? What it is? It will release moisture. All these plants and everything which we plant, it will release moisture, and it will make our atmosphere cool, and it will bounce back the sunlight coming from the sun. And by bouncing back the sunlight, it will improve the urban design for a better airflow and constructing energy efficient buildings. What is energy efficient building? A building which uses less energy. For what all things we are using the energy? For energy for a building, it is electricity. For what all things we are using? We will use it for a fan. We will use it to run an HVAC system. We will use it to run a refrigerator and all those things. No. So whenever we are planning all this thing, whenever we are planning a green infrastructure, along with your green infrastructure, or along with your house or whatever construction you do, it will reduce using of all these resources. It will all these resources, and it will become an energy efficient building. Okay, so the green infrastructure, what all things are coming under green infrastructure? First one is trees and vegetations. Trees and vegetations can provide shades. It can release moisture and absorb pollutants and cool areas significantly. That's a impact trees and vegetations which does in our environment. Next one is green roof. Before we said, green roof or vegetable gardens or what? Green walls. Green walls means this vertical gardens and all. It can insulate a building. It can reduce the heat absorption and offer cooling through plant transparency. Green roof, it will insulate the building. The green roof will act as a layer outside the building, and it will collect it will resist all the heat and for whatever things which is coming over that building. Next one is green pavements, permeable surfaces that cools through the moisture evaporation and reduce heat retention. Next one is cool materials and surfaces, cool roof and walls, high reflective materials that send solar radiation back into the atmosphere, reducing the surface and indoor temperatures. So whenever we are painting a terrace, what color we have to use? We will use the white color, right? Why we are using the white color? This white color will reflect the solar radiations back. It will not absorb the heat energy. It will send the heat energy back, and it help in reducing the room indoor temperature. Whenever the room indoor temperature is get reduced, what will we do? We will stop using AC, or we'll stop using fan. Okay. Next one is light colored pavements. Reflect more sunlight than dark asphalt, lowering heat absorption. Okay, what is the color of asphalt? We all have black roads, and it will absorb all heat and everything. If we can provide light colors roads, light colors pathways, and what, it will not absorb that much heat. It will reflect the heat back. Next one is urban design and planning. What I have told before, whenever you get a chance to design a town planning or a urban space or what, you have to add all these things. You have to add shading, strategic placement of trees and buildings to create shaded public areas. Then albedo enhancement increases the overall reflectivity of the urban landscape. Water features evaporate cooling from ponds, fountains, and streams. All these things we can implement in our designs. Okay, shading means what? We can plant more trees. It will act as a shade for our public spaces. It will act as a green canopy for our public spaces. Then the urban landscape, it can reflect all the heat and everything back. It will not absorb it, it can reflect. Then water features, evaporation, cooling from ponds, fountains, and streams. You introduce all these things. You introduce water bodies into our designs. It will send all the things back, and it will try to, or we will get our temperature down by doing all these things. Then energy efficiency, that is energy efficient building. That is, whenever we are implementing green infrastructure or cool materials and surfaces, we can make our building energy efficient, and it will reduce internal heat generation from appliances and HVAC systems. Whenever we are making a building energy efficient, what it will do, definitely the usage of HVAC and other appliances will come down. Okay, going to the next slide. Stormwater management. The second one is stormwater management. How can we manage the runoff water? How can we manage the runoff water? It is a practice of controlling rainwater runoff from developed areas to prevent flooding, reduce pollution, and protect infrastructures and ecosystem by managing the quality and quantity of water flowing into the natural waterways. It is a system of preventing the flow of runoff water. Then it will prevent flooding. Whenever it rains, whenever all the pollutions, all the pollutants from the road and everything, what happened? It will like go into the nearby water sources and it will get polluted. So by implementing stormwater management system, we can reduce those pollutions. We can reduce those pollutions. We can reduce the pollutions in our natural water bodies, and we can protect infrastructure and ecosystem by managing the quantity and quality of water flowing into our natural ways. If the quantity of water increases, flood will happen. If the quality of water decreases, our natural water sources will get polluted. So green infrastructure uses natural systems like rain gardens, biospheres, and permeable pavements to absorb and filter water whether it falls. So whenever we are designing something, we have to introduce a green infrastructure into that. So that green infrastructure, what it will do, it will absorb the water. It will reduce the runoff of water. It will absorb the water and filter wherever it falls. Otherwise, what will happen? The water will fall somewhere and it will run off into the nearby water sources and it will go like that. So we have to make some arrangements to trap that water, to absorb that water, and to keep that water there itself where it falls. Next one is structural controls. Traditional systems like detention ponds, pipes, and catch basins to collect the direct runoff water. Again, all these things are gray infrastructures. We can build detention ponds and all. Okay, we can use some gray elements in that. We can use some cement and all, no problem. But build those things and catch all the direct runoff water and prevent the water from flowing directly into the water system. Next one is source control. That is what I have talked before. Practices like proper care maintenance, picking up pet waste, and use eco-friendly lawn care to reduce pollution at its source. Actually, when it rains, the water will come into our ground. From that ground, the water will get polluted because we all have all this waste and everything in our ground. This rainwater will get polluted from the source itself. Which one is the source? Our immediate ground is the source. This rainwater will flow out there and it will get polluted from that space. And from these polluted waste is directly going into our water bodies. So we have to control the source. We have to control the pollution at the source itself to bring or to maintain that pollution and everything into our natural water bodies. Next one is policies and planning, regulations and city designs that incorporate stormwater management into development. Government should implement policies and planning. These strong policies and planning, whenever we are building something new, if government is saying, okay, you have to get all these things done, if they're telling like that, then people will do that. They have to put strong policies and implement, and even they can put fines if we are not obeying that, we are not doing that, because it is very necessary to do that. Sorry, one of my slides come before. Next one is coastal protection. So coastal green infrastructure uses nature-based solutions like land, reefs, dunes, wetlands to protect coast from erosion and flooding, offering benefits like better water quality and carbon capture. This system works by mimicking natural processes to absorb storm energy and filter water, creating sustainable defense against rising sea levels and extreme weather. That is coastal protection. We talked about coastal protection before, right? So coastal green infrastructures uses natural-based solutions like plants. Okay, there's nothing like a big. There's no rocket science in that. We are just using plants and reefs and dunes and wetlands, and with that we will protect our coast from erosion and flooding. And what benefit it will give? It will give a better water quality, because whenever the water is flowing into our water source, whenever it is flowing through a vegetative land or something, maybe the polluted thing, the pollutions will get filtered through that water, that vegetation, and a good quality water will come inside our water source. Then it can capture carbon, and this system works by mimicking natural processes to absorb storm energy and filter water, creating sustainable defenses. Because whatever things we are doing is we are mimicking from nature, because it will not affect our nature back. So if we are creating some gray infrastructure into this, again, we have to take some renewable or non-renewable source of energy or raw materials to build this up. So if we implement this green infrastructure, it is like mimicking the nature, and it will not affect the nature back. So living shorelines, that is combination of plants, sands, and natural structures to stabilize shorelines, including dunes and beach nourishment, restoring or building sand dunes with vegetation to act as a natural barrier in beach and all. Okay, we can build the sand dunes and we can give vegetation to that, and it will act as a natural barrier, and it will like keep the waves and everything aside. Wetlands and mangrove, coastal wetlands and mangrove forest buffer wave energy and trap sediments, reducing erosions. Okay, this wetlands and mangrove, it can hold the soil there. It can hold the soil there. It will reduce the flow of runoff water, and it will keep our water sources and everything in a good place. Next one is vegetative buffer, that is salt marshes and coastal grasses that absorb flood waters and filter pollution. All these things. Next one is air and water quality. Next, and this is the last thing. I think I'm running out of time. Next is the last thing, that is water and air quality. Green infrastructure adapt to climate change for better water and air quality by using natural systems like roof gardens, the rain gardens to absorb storm water, filter pollutants, reduce urban heat, and directly trap particulate matter, enhancing urban resilience against heavy rain, heat waves, and poor air. These switches manage flood. It will improve the drainage conditions. It will cool environment and sequester carbon, offering suitable solution to climate impacts. Okay. Next, when we are introducing this green infrastructure, it can easily like bring up the quality of air and water. How it bring up the quality of water? That is, first one is pollutant removal. Plants and soil filters out sediments, bacteria, nutrients, heavy metals, and hydrocarbon from polluted runoff before it reaches the river. That is how this green infrastructure is like making the quality of the water good. It will remove the pollutants. It will remove the pollutant from the runoff water. It will remove sediments. It will remove bacteria, heavy metals, and all other things from the runoff water before it reaches the river. So the water in a water source will be in a good condition. Next is water retention and reuse. Green roof and rainwater harvesting system captures water. What is a rainwater? Before I said about rainwater harvesting system, no, this system will capture water. They will keep the water, and we can reduce by keeping this water. The amount of water flowing into a water body will get less. The amount of water will get decreased, because if the rain is giving some 50 liters of water, if we can keep a 25 liters of water, then the other 25 liters will run into the nearby water body. So it will reduce the quantity of water which is flowing into the water body. By that, we can reduce the chances of flood. And providing what these water which we are keeping, we can use that water for irrigation. We can use it for water supplies. We can use it for household activities and all. Next one is natural buffers. Restored wetlands and floodplains act as sponge, holding excess water and providing and protecting against erosion and flood. That is natural buffer. That is over the soil, all the leaves and everything will be there, and it will act as a sponge, and it will hold the excess water, and it will protect it. So if all things are there, it will hold the water, it will reduce the speed of runoff water, and it can act as a natural buffer against erosion and flood. And the last one is air quality adaptation. That is pollutant filtration. Trees, green walls, and vegetation directly capture particulate matters and absorb harmful gases like nitrogen, oxygen, improve local quality of air. Whenever we are in a city, whenever we are in a town, and if you're going into a park where it is filled with trees and all, we cannot see much pollution in there, because all the trees, it will directly capture these particulate matters. It will breathe in all unwanted gases and all, and it will give good quality like oxygen, and it will improve the local air quality. Then urban heat island, that is an effective mitigation method. That tree provide shade and plants cool through the moisture releases, lower the urban temperature during heat waves, which also slows down ozone formation. Okay, again, when we plant more trees, these trees will it will act as a barrier from the sunlight. It will give moisture, it will release moisture, and it will lower the urban temperature during the mid-peak heat waves and all, and it also slow down ozone formation. And again, one of the most important thing is carbon absorption. That ozone or carbon formation or carbon is carbon is impacting our environment. So carbon absorption, vegetation absorb carbon dioxide, helping to mitigate overall climate change. So to conclude on my topic, to have a brief conclusion on my topic, the green infrastructure is no longer an optional subject or aesthetic addition. So the green infrastructure or GI is no longer an optional subject. It is not an optional subject. We have to include this in our curriculum. We have to make our coming generation aware about green infrastructure. We have to tell them the importance, and we have to teach them, or we have to teach them the impacts what's happening right now on our environment. Now we have to teach them, and we have to tell them the importance of green infrastructure. It's not longer an optional subject, or it's not longer a gimmick subject. It is a necessary subject which we have to implement. It is a fundamental need of today's climatic changes. To control the climatic changes, to give something back to our Mother Earth, we have to implement green infrastructure. Anyways, we have to we should have the green infrastructure and everything. We should have, because in the previous slides we discussed about infrastructures and what that is necessary for the growth of the country. But along with that, we have to implement green infrastructure also. It may not completely offset our climate change impact, but it can significantly enhance a city's adaptive capacity. Even if we implement this, it cannot completely offset all climatic changes. If we plant 2 or 3 trees, tomorrow morning I'm going and waking up and I'm planting 3 trees, it doesn't mean everything is under control. But it can significantly enhance the adaptive capacity of our environment. So successful future implementation in green infrastructure require multidisciplinary collaboration. That is the government sectors, the private sectors, and communities, and evidence-based guidelines tailored to local climatic conditions. Everybody have to collaborate together to bring this into action, to bring this subject into action, and to implement this green infrastructure. So green infrastructure, it is very necessary to control our climate, to control the changes which is happening with our climate now, to control the changes which is happening in our environmental nowadays. And it is a very important subject. It is very much needed. All the civil engineers out here, all the teachers out here, all the civil engineering students out here, you should have keep this in your mind. You should have, everyone have to act for this. And whenever you are designing, whenever you are planning something, whenever you are going to construct whenever you are going to construct an infrastructure or a building or something, you have to keep in mind that you have to keep a word green in that. Not only a word, you have to provide a space for that. You have to design a space for that, and it will help our future generation to have a good earth, to have a good environment. That's all about from my side. Thank you. Thanks a lot.
Thank
Hello?
you, sir.
Yeah.
Next is the question answering section. Before that, we have to share some important things about this FDP. Is it okay, sir?
Yeah, no issues.
Okay. During that time, participant can post enquiries in the
Can
chat
I
box.
can I stop this? Can I stop this thing? The PPT, sharing this PPT.
Okay. Okay, sir.
Tomorrow is the last day of our FTP. The session will start from sharp 3:30. 3:30 to 5 o'clock, we are having session 12. And 5 to 7:30 session 13. And 6:30 to 7:30 is the online test. So everyone should participate in the online test, and you have to score the above cutoff mark. So the session is online test is from 6:30 to 7:30. After that, 7:30 to 8 o'clock validatory function. In that also you have to attend. Then only that we will wind up our FTP. So tomorrow the session will start from 3:30 to and it may end at 8 o'clock. And during this session, you have to fill the feedback about the session and feedback about the FTP, and you have to clear the online test. Also, you have to fill a reflective journal. That also you have to fill. So there are a lot of procedure tomorrow. So hope everyone will cooperate. Thank you. Thank you once again.
Okay. There is one question in the chat box. Sir,
Yes. Yeah. Tell me.
what type of green infrastructure is most effective for flood-prone regions?
For flood-prone regions, if you can planting trees which can resist this thing, with roots which is going like inside no beneath, which can resist the flood, no, or the shrubs and all, no? Small plant shrubs and all. If you can plant that in the flood-prone area, it will reduce the impact of flood. Anyway, flood will come. Flood will, or else we have to like control all the runoff water and everything. So it will reduce the impact of flood in the flood-prone areas. Okay. The reef, the barriers, etc., you can like implement for that.
Okay, sir.
Sir, excuse me, sir.
Yeah, tell me.
Sir, can you please discuss about the major challenges in implementing the green infrastructure in Indian cities?
Major challenges in implementing green infrastructure in Indian cities.
Yes, sir.
First one is, I will say the lack of education. First thing is we have to educate everybody about this. Second one, maybe high cost. That initial cost will be very high. Planting trees, making gardens, making parks and all, no? The initial cost will be high. Then in our urban areas, we do not plan any space for this, because in our existing urban areas, there's no space for like for a green area, for a park or what, there's no space for that. So the scarcity of land is another issue. Then before I say the lack of public awareness, we have to like give proper awareness for our society, to our society regarding this. What we are doing is like we will be using whatever things we have, and we are not giving anything back to society or anything back to the environment. We have to give proper awareness for that. And then another thing is, if we are doing something, okay, for example, I will take park as an example. We build a park, we will not maintain that. We have to do in India, we have to do that. We have to like implement laws and everything for that. I think these are the challenges in India. In India, these are the challenges in implementing GI. But we have to overcome these challenges and we have to implement it. Then only things will get into control. Thank you.
Thank you, sir.
Good evening, sir. Dr. Suhail from Srinagar, J&K, sir. I have a question, rather two questions, sir.
Yes,
The
sir. Tell me.
So the first one is, how does the green infrastructure differ from the conventional green infrastructure in terms of life cycle cost, resilience, and environmental impact? The second question is rather than a technical question from my native state or from a native place. How can we customize this green infrastructure in the regions having the extreme weather conditions as far as the state of Jammu and Kashmir is concerned? How can we pivot the role of this infrastructure in these zones, sir? Sir, please share some light on this topic.
Yeah, I think first I'll answer the second question. For the extreme weather conditions, again, we have to get ideas from the local people. I think there's something which grows over there, no? Extreme to reduce the what's happening there is before I said no,
So
as the temperature, yeah.
Sub-zero temperature conditions, and also there is another thing that the construction material that we utilize also sometimes fail due to the durability actions of the freeze and thaw. So that is the main challenging action.
That's a major challenges we are facing over there. And again, we have to reduce the overall temperature of the environment, of the overall earth temperature. I said no, it is again day by day it's increasing.
Yeah, in the other part of the country where we try to minimize the heat loss such that we don't want to generate the heat within the infrastructure. Here it is totally the other side of the coin. We try
other side,
other side of the
other side. Okay, thank you. Then anybody else?
Sir, one question is in the chat box. How do we measure the success or effectiveness of green infrastructure projects?
To measure the success, maybe we can check the changes. We can track the changes in the quality of the environment. Maybe data collections, surveys, and all. Whenever we are implementing something, we can see the changes, no? So we can track the changes. We can track the changes of the quality in the environment, and that's how we can measure the success. And it will not happen all of a sudden. It may take time. It is not like we are building something. Okay, we will get the end result in a few days or few hours. It doesn't happen like that. It will take some time, and we can track that quality of air and all. We can feel the difference. And again, data collection, we can ask our local people, okay, how you are feeling now. We can see the diseases and everything is going down and all. We can track like that. Next, anything else?
No, sir. Okay. Then.
Okay.
The session is over.
Everything is over. Thank you very much. Thank you for listening to me for last, I think, 1 hour I have taken now. Listening to me. Thanks a lot.
Thank you, sir. On behalf of the organizing team, all the participants, I sincerely thank our esteemed resource person for the enlightening and well-structured session. Your valuable insights and practical approach have greatly enriched our understanding of the session. We truly appreciate the time and effort you have dedicated to this FTP. Thank you once again for your valuable contribution. I also thank all the participants who attended the FTP. Thank you all. The feedback link of the session 2 is in the chat box. Stay here and kindly fill the feedback link.